All right, so let's just talk about number one. If you've moved on, come back. Calculator's down, and I want to make sure you're listening to and paying attention to what we're talking about here. So, our first priority in each of these is recognizing that we're told that they're right angles. So, as soon as we see that they are given to us as right triangles, we can right away identify the hypotenuse. Now, if you've been doing these for a while, finding the hypotenuse is no big deal. But if you're rusty, or if this is new to you, if you take the time to think about and identify which of the sides of the triangle is your hypotenuse, it's going to prevent you from making an awful lot of mistakes that lots of kids make. If you are a person who's always assuming that their unknown side is the hypotenuse, that'll help you out with A and B, but definitely not with C and D. Because for C and D, my unknown side is one of my legs. So if you did not set up your Pythagorean equation correctly, you're not going to have no shot at getting the right answer. All right. 4 squared plus a squared is equal to c squared. I square 4, I square 8, I add them together. And I have to be able to express my answers in two ways. I need an exact value and a value that's rounded to the nearest hundredth. So, as a review, when I'm looking at taking the square root, you want to use this second function button and this squared button. And then inside of the radical sign, you want to type your value. And then when you press enter, there you go. It's trying to focus. That little blue dot. So when I go to round to the nearest hundredth, the way this works is you come out one decimal place too far. So here's my tenths, here's my hundredths. I'm going to come out to my thousandths, and I'm going to take a look at this third decimal. If it's a 5, a 6, a 7, an 8, or a 9, I'm going to go ahead and round up. Think of it like money. The cash register is going to call this $8.94. It's not going to round up to 95 cents. Got it? So we'll go ahead and just call this $8.94, 8.94. And that squiggly sign lets everybody know, hey, everybody, that's an estimate. It's pretty close, but it's just an estimate. When it comes time to talking about exact values, the square root of 80 is the exact value. The problem is, in mathematics, we like things simplified. So this work that I did up here is my process of how I break down 80. Now here's the thing, I'm looking for my best friends everywhere I go. I'm looking for all those numbers back here behind Stephanie. I'm looking for 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196. I'll even go up to 225. I can list my perfect squares just like I can list all the people invited to my birthday party. They're my best friends. So when I start looking at 80, I know 80 is 8 and 10. I know it's 2 and 40. But I'm going to find 4 in it first because that's one of my perfect squares. Once I get 4 and 20, I'm like, oh snap, I got another one. So 16 goes into 80 5 times. 16 is a perfect square. I could have started there. But that's outside of my friendly numbers. If you have a double factor, that is the same as taking the square root of 16. Square root of 16 is 4. So when I simplify that radical, my 4 comes out, my 5 has no double factors, and he's stuck inside. So we're going to continue to review this simplifying radicals as we go. Here's your job. Ask questions when you don't understand. How'd you get that? Where's that number come from? Tell me again how to do it. because in geometry teachers' minds, algebra kids know how to do this. In COVID, algebra kids' minds, you're like, yeah, we never learned that. Right? You're like, okay, they showed it to us, but I never actually learned it. So this is where it's time to learn it, to catch up. That's one of those skills we're going back and reviewing. So you need to make sure you're asking questions. So no tuning out, no checking out, no drawing on your papers, no pretending like it's not going to count. Because if we go over it enough times, I'm expecting you to be able to do it on the test. You need to be able to do it. So you ask yourself, does that make sense to me, yes or no? If the answer is no, your hand's in the air, you're asking a question. Got it? All right, for the next one, C is what I'm missing. 7 squared, C squared, okay? Add them together, get 98. Do you see the perfect square here? What kind of triangle is this? It's a right triangle. What else? It's isosceles. Because it's an isosceles triangle, I'm going to have 2 of those squares being added together. So now that you see that, does that make sense to you? I can break that down into 2 times 49. 49 is a perfect square. Every time that I find a perfect square, I'm super excited because those perfect squares are what can come out of my radical sign. I do want to talk to you about taking the square root of 98. And this is a hard one to round. So ask yourself, if something costs $9.89.9, what is the cash register going to call it? 90 cents. So this rounds up to 9.90. This 9 here bumps this 89 up to the next level. Does that make sense to you? So we need to make sure 2 things are true. You can simplify a radical and you know how to round. And that's the trickier kind. So there's easier kinds and trickier kinds. That's definitely a trickier kind. Got it? All right, the next 2. If you set them up correctly, they were easy to do. If you saw that this was a leg and not the hypotenuse, you knew where to put it. So it works out evenly. Woohoo! Now, if an algebra teacher walked in, she'd be upset with me because when you take the square root, you're supposed to consider the positive and the negative root, and I get that. So really the 2 answers here are 8 and negative 8, and really you then have to take the time to cross this out because we're not going to have a negative distance. So the Algebra 2 teachers are going to make sure that you know when you take the square root, when you draw the square root sign, when you take the square root of each side of an equation, you have to watch out for 2 possible values for x, a positive and a negative. The geometry people are like, yeah, but the negative one is always extraneous. But we still have to think about it and consider it and be like, nah, he's not going to work for us. So that's the better way of doing this. When I take the square root of each side, true story, positive, negative, this is an extraneous solution. How come this answer is only written once like this instead of having 2 values for these up here? Why are these written once and those I have 2 values? How come, Cece? Yeah, because my outcome, 64, 36, those are my best friends. So when I take the square root of a perfect square, I get a whole value. Kind of cool. Trick question. You ready? Which one of these 4 is a Pythagorean triple? Talk to your group mates. Go.
This one has
Yeah.
All right, come back. Who has an answer for me? A, B, C, or D? Where's my triple? Philip, what do you see? It's definitely C. Why not D? I got an answer. Why not D? Yeah, check out this guy. So if it's a triple, all sides of the triangle have to be whole values, not just your answer. Not just 6. So 6 is a natural number. It's a counting number. It's good. That's a whole positive value. So that definitely is cool. So is 3. Root 45. It ruins it for the rest of us. But it's hard to see because when I square, and this is another thing for you guys to figure out mathematically, when you square a square root, it's just that thing that's inside. If I want the square root of something and then I square it, it's just that thing that's inside. Your squaring and your square roots are inverse operations. Kind of like my reciprocals are inverse operations. A positive and a negative, inverse operations. Tying your shoes, untying your shoes, inverse operations. So when we're talking about squaring a square root, it's just going to be whatever is living underneath that radical sign. Make sense? All right, on to numbers 2 and 3. Determine if each set of values can represent the sides of a triangle. If yes, tell me, is it obtuse, right, or acute? And then number 3, sketch that triangle and solve it. On your mark, get set, think. All right, let's check it out. First of all, I'm going to identify which is the largest side of the triangle. So I have 10. So I need to know, is 9 plus 7 greater than 10? Yes, that's true. So now I have to see if it fits a Pythagorean story. How does 9 squared plus 7 compare? And it's nice to put C over here. So when I'm looking at filling in this idea of how does it fit in. So I know that this is 100. How does that compare to 81 plus 49? So 100 I know is less than, because 81 plus 49, correct me if I'm wrong, 130? So because this is smaller, therefore my triangle is an acute triangle. I know it's scalene because each of the sides is different, so I can go ahead and classify that triangle as acute and scalene. All right, let's talk about this guy. If I'm talking about 5 roots of 2, I know that 5 times the square root of 2 is going to be bigger than 5. When I check it out, I have, that's about 7-ish. So when I talk about is 3 plus 5 bigger than about 7.07? Yeah, because this is 8. So is this a triangle? Yes, it's a triangle. So now we'll go ahead and say, okay, talk to me about 5 roots of 2 squared and compare that. And this circle that I draw is just kind of holding a space for where 3 squared plus 25 squared sits. So 5 times the square root of 2 squared is the same as 5 squared, which is 25. 25 squared to 2 squared is 2. So that's 25 times 2, so that's going to be 50. If I'm comparing 50 to 9 and 25 squared, wow. Right? No, 25 is already squared. What the heck? Hold on. I squared it in my head. 5 squared, so this is 25. How am I doing now? So now I have, how does 50 compare to, my goodness, I'm falling apart today. How does 50 compare to 9 plus 25? Does that sound like 34 to you? Isn't 50 bigger? Therefore, it's going to be an obtuse triangle. And of course, it's scalene because all my sides are different. Remember, your first step has always got to be check and make sure that it is a triangle. All right, let's talk about this one. Square root of 10, I need to know what that's worth. So we'll go ahead and say square root of 10. That's about 3. So if I say this is about 3.16, square root of 10, this is my biggest side. So is the square root of 10 plus 12 greater than 18? So here's the square root of 10. If I add that to 12, is that bigger than 18? No. So guess what? This one is not a triangle. Until I have the sum of my two smaller ones bigger than my third side, I know I don't have a triangle. That's why it's important to check that out each time. All right, next up, the hypotenuse of a right triangle is 9 centimeters. One leg is 4 centimeters. Sketch the triangle. All right, so go ahead and sketch any right triangle. It doesn't matter what it looks like. Your hypotenuse is 9 and one leg is 4. Determine the length of the other leg. I'm just going to call it x. I know that 9 squared is going to be equal to 4 squared plus x squared, 81, 16. So my x squared is equal to, what's that? 71, 65? Did I get that right? 65. So when I take the square root of each side, x is going to be equal to, let's see what the square root of 65 is. So that's going to be about equal to, rounding to my nearest hundredth, 8.06. When I go to figure out, I've got 5 and 13 as my two factors of 65. So guess what? There's no simplifying necessary. There's no perfect squares that live inside that number. So when I go to express it as both an estimated and an exact value, it's real quick and easy. I don't have to worry about simplifying that radical because I can't. How are we doing on that? With your group mates, please, will you go through and talk about problems 1, 2, and 3 and say which one do you think is the hardest? You mark, set, go. So Nicholas and I were talking, and he just has an answer on his paper, and I was like, how's that done? He's like, I did a little work on a calculator. Totally okay with that. But what we need to see is your initial equation. So for this class, if you don't show me the work, even if you do it on a calculator, you're not going to get full credit. So what I need to see is, I knew this was my setup, and here's my answer. So if you skipped this part because you did it on the calculator, I get it. But if you got the answer wrong, you need to be able to go back and be like, where did I screw up? You need to be able to go back and look at and see where it was that you went south. All right, solve for x, state if the measures represent a Pythagorean triple. Yes, because these are all whole values. No fractions, no radicals. This one, why no? Yeah. And notice I show my work over here on how I split out. Again, I'm always, whenever I simplify a radical, I'm looking for my best friends. So if you did 32 as 8 and 4, that's fine. You can keep breaking them down. I'm going to zoom in and try to find my best friends every time. C and D. Yes, this one's a Pythagorean triple. No, this one's not because of these two radicals here. Nice how this works out. Super. Awesome. But no, it's not a triple. All right, E and F. Yep, look at that. Were you so excited when you went to take the square root of 2025 and you were waiting for some decimal? You're like, oh, see, math is filled with good surprises. Wasn't that fun? And then here we have a triple. Yes. And this was the same triangle relationship as the other one. Go ahead.
So, on D up there.
Yeah.
How did you get 64.6 out of?
Okay, because when I square this exponent travels to each factor. So this is 8. So when I square 8 root 6, that's 8 root 6 times 8 root 6. 8 times 8 is 64. Root 6 times root 6 is 6. Now you can type that into the calculator. I just prefer to use my brain. Every chance I get to do math in my brain, I do. I did the same thing here. So 8 times root 15 squared is 8 times root 15 times 8 times root 15. That's 8 times 8, that's 64. Root 15 times root 15, that's 15. So then I can do that math in my head. Sound okay? Awesome, thanks for asking. All right, determine if each triangle is obtuse, right, or acute. Now, I got to tell you something. Sometimes I forget to wait. I forget to see if it's even a triangle, right? Anybody do this? Anybody get caught? So what ends up happening, if you get a ridiculously obtuse triangle, if your C squared is super, 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 super big, take a moment and be like, oh, wait, did I forget that this is actually not a triangle? Because 19 plus 14 is 33, so that can't be a triangle. Mr. Logan told his kids if they see a triangle with values on it, to just assume it is a triangle. And I'm like, oh, I hope they do okay with the homework. All right, here we go. Here again, when I'm squaring my radicals, 5 root 5 times 5 root 5 is 5 times 5 times 5. 3 root 2 times 3 root 2 is 3 times 3 times 2. Are we good on page 1? All right, let's look at page 2. Determine if each set of values can represent a triangle if yes. So it's more of the same thing. You almost start wishing for these because it's so much less work. So you're like, come on, lucky, not a triangle. Because it's so much less work. Trying to think about why I have X's on these two. Oh, I know why. Oh, shoot. This homework, the altitude to the hypotenuse of a triangle. Yeah, you don't, that was from a past unit that I should have taken out. Darn it. Did you struggle with these? The altitude, hypotenuse, or a triangle, that's my mistake. Yeah.
It doesn't say the altitude.
Oh, is your one better?
It says the hypotenuse of a right triangle.
Nice, because you have the newer version. I forgot I changed it. So I have the hypotenuse of a right triangle. Let me go back and get, because this is an old key from last year. Oh snap, I gotta fix this. Hold on. Let's see what the new homework says. Hypotenuse of a right triangle is hypotenuse of a right triangle is 6 centimeters, and one leg is 2 centimeters. Sketch the triangle and determine the length of the other leg. So we're okay. We agree. Hypotenuse of a right triangle is 15 centimeters. If the long leg is 9 centimeters, what's the length of the other leg? We're okay with that. What is the length of the other leg? So we're okay with that, right? Shoo. Okay. Old key. Solve for x and y. Hey, it's isosceles. Did you miss it? So x is equal to y. So I can substitute my x squared in, and I can go for and solve it. Everybody okay with that homework? Okay. Back to your warm-up, please. We have one more Unit 4 thing to teach you. One more. Big idea. Are you with me? Okay. So the hinge theorem and its converse. So I don't know if I've ever told you this or not before, but I had the pleasure of teaching my own children. Right? So when I was a 6th grade teacher at Clearview, my 2 boys came through my class. That was fun. Mom was their 6th grade teacher. And I feel worse for my daughter because by the time my daughter came through, I moved up to the middle school and I was teaching geometry at the middle school. So Caroline came through in the geometry class. That was, Caroline and I butt heads a little bit, I guess, mothers and daughters given. So when we got to the hinge theorem, she raises her hand in the middle of class in front of all of the students, and she's like, "This is the dumbest theorem." And every time I get to a hinge theorem, I think of Caroline. I channel my Caroline, because I got to tell you something. I couldn't disagree. How about that double negative? Of course, I agree. And so she started calling different theorems that we talk about in geometry. Oh, that's a duh theorem, like duh. See, she had duh before Billie Eilish did, like duh. Okay, give me your thumbs and give me your fingers. Pencils down, thumbs, fingers. Ready? The hinge theorem goes like this. If you have 2 sides of a triangle that are congruent, so your thumbs, unless you're a freak of nature, I'm kidding, we're fine. Your thumbs are basically the same length. Your pointer fingers are basically the same length. Mine is particularly fat because of a softball injury. Again. If I make a triangle out of these 2 situations where this third side is this imaginary side between my pointer and my thumb, here's the duh part. Are you ready? If this angle is smaller than this angle, this length is going to be smaller than this length. Duh.
That is dumb.
That's the dumbest theorem I've ever heard in my entire life. But it's guaranteed to be on some kind of test, and you're going to be like, wait a minute, what backs that up? That's the hinge theorem. Sometimes when I teach the hinge theorem, I bring out my claws because they're bigger, and that can help you see it better. If I have 2 legs of one triangle that are congruent to 2 legs of another triangle, whichever triangle has the larger included angle, that third side is going to be longer. So this distance is longer than this distance. Everybody together. Duh. Are you with me on that? So the converse says the exact opposite. The converse says if 2 sides of one triangle are congruent to 2 sides of another triangle, and the third side is longer than the third side of the other triangle, then the included angle of the first is larger. So the hinge theorem and its converse we include because we have to, and we want to remember its name, and we're going to be tackled with problems that you're like, wait, how do I know that's true? I know that the distance from R to T has to be greater than the distance from V to X. This is longer because this is larger, and these 2 sides are congruent. I know that the measure of angle A is larger than the measure of angle D because 8 is bigger than 7. With your group mates, 1, 2, and 3 on your mark, get set, go. Talk about it. All right, how do we do? Because I know that this side is congruent here and these sides are congruent here, and we want to make sure we're talking about our included angle. It's got to make sure that you talk about our included angle. Because of that included angle, because 50 is bigger than 42, I know that KL, the distance from K to L, has to be bigger than the distance from M to N. That's why M to N is smaller than 19. So it can't be 22, it can't be equal, it has to be smaller. Because I see these congruent sides, these two congruent sides, and I have this 20-degree angle here, because this value is smaller than this value, I know that C has to be bigger. This angle opposite the larger one has to be bigger. Therefore, C can't be 20. It's got to be bigger than 20, which makes it 25. What can you say about the lengths of AR and RB? The distance from R to B has to be bigger. What are the possible values for X? And here's a tricky diagram. You might miss that this is the shared side, right? So it's congruent to itself. So if you're doing your little fingers, pretend like your thumbs are one triangle, right? Right? So this is a shared side. So you know that the value in here has to be smaller because 9 is smaller than 12. 3x minus 9 has to be smaller than 36. Therefore, x has to be smaller than 15. Sound okay? All right.